Hello students, welcome to EPG Pathshala. I am Rashmi Sinha from Indira Gandhi National Open University. Today we are going to talk on the module Nutritional Adaptation in Man from the paper Human Growth, Development and Nutrition. The objectives of this module are to understand what is nutrition, the main nutrients essential for our body, to understand the energy requirement of human, and to understand the nutritional adaptation with the example of lactose intolerance. To understand comparative dietary and nutritional adequacy of hunters and gatherers and of agriculturists and pastoralists. Also to understand the association between protein and population density, and to understand nutritional adaptation in extreme environments, that is in the high altitudes, cold climate and hot climate. Foremost for us is to understand what is nutrition. The nutrition is defined as a process of taking in food and using it for growth, metabolism and repair. In other words, nutrition or nourishment is the supply of food required by the organism to remain alive. There are 5 nutritional stages: ingestion, digestion, absorption, transport, assimilation and excretion. Good nutrition is well-balanced diet combined with regular physical activity, and it is very important for good health. Poor nutrition can cause reduced immunity, increased sensitiveness to diseases, reduced physical and mental development. Today, as molecular biology, biochemistry, and genetics advance, nutrition has become more focused. Nutrition deals with identifying how certain diseases or problems may be caused by dietary factors such as poor diet, which is called malnutrition, food allergies, metabolic diseases, etc. Nutrition also focuses on how diseases and problems can be lessened or can be prevented with healthy diet. The main nutrients essential for body. Now, what is nutrient? A nutrient is a source of nourishment in food. According to Medical News Today, the human body requires majorly 7 types of nutrients. They are carbohydrates, fat, protein, fiber, vitamin, mineral and water. Nutrients can be divided into 2 categories, the micronutrients and the macronutrients. Macronutrients are nutrients that are required in relatively larger extent, and micronutrients are nutrients that are required relatively to smaller extent. Most of the food contains a combination of some or sometimes all of the 7 nutrients. We need some nutrients regularly and others less repeatedly. Poor health may be the cause by either due to deficiency or due to excess of nutrients. Energy-giving macronutrients. These nutrients provide energy to the human body, and they are measured in kilocalories or joules. Carbohydrates. Molecules of carbohydrates consist of carbon, hydrogen and oxygen atoms. Carbohydrates can be monosaccharides like the glucose, fructose and galactose, disaccharides and polysaccharide, that is starch. Polysaccharides are more aided for human because they are more complex sugar chains and take longer time to break down and absorb into the food. Excessive increase in blood sugar levels are linked to heart and vascular disease. Protein. Molecules of proteins contain nitrogen, carbon, hydrogen and oxygen. Simpler proteins are also called monomers, are together forms complex protein called polymers, which function in building and repairing of tissues. When proteins are used as fuel, is required to break down, as it breaks down into nitrogen, which is eliminated by the kidneys. Fats are triglyceride. It consists of 3 molecules of fatty acids combined with molecule of alcohol, glycerol. Fatty acids are monomers, simple compounds, and the triglycerides are polymer complex compound. Now, what are the other macronutrients? They do not provide energy. That includes fiber. They consist of majority of carbohydrates. Because of its limited absorption by the body, the sugars and starches not much get into blood stream. Fiber is essential part of human nutrition. Water. Nearly about 70% of the mass of the human body is water. How much water the human body needs, nobody is completely sure. The claims vary from between 1 to 7 liters per day to avoid dehydration. Water requirements are very closely associated to body size, age, physical activity, environmental temperatures, different state of health and dietary patterns of people. The people who consume a lot of salt will require more water than those who consume less salt, even if they both are of the same height, age and weight, exposed to the same level of external temperature. We just talked of macronutrients. Now let's see the micronutrients. These nutrients are required in relatively small quantities throughout a person's life. Minerals. The term mineral is misleading. It would be more relevant if called dietary ions. The experts at the universities of Florida say that 16 key minerals are important for human biochemical processes by serving functional and structural roles and also as electrolytes. Now, what are these? Let us see. Potassium, chloride, sodium, calcium, phosphorus, magnesium, zinc, iron, manganese, copper, iodine, selenium, and molybdenum. Now let's learn about each of them. Now potassium is a systemic electrolyte essential in co-regulating ATP, which is an important carrier of energy in the cells of in the body, with sodium. Deficiency of potassium leads to hypokalemia and excess leads to hyperkalemia. Chloride is crucial for hydrochloric acid production in the stomach and also important for cellular pump functions. Deficiency leads to the hypochloremia and excess leads to hyperchloremia. Sodium. Sodium is a systemic electrolyte. It is essential in regulating ATP with potassium. Deficiency leads to hypoatremia, which causes cells to malfunction. Extremely low sodium can be fatal, and excess leads to hyperartemia. And according to the American Heart Association, the sodium consumption should be limited to 1500 milligrams per day. Calcium. It is important for the muscles, heart, and digestive health. It is important for building bones, helps in synthesis and function of blood cells. Deficiency leads to hypocalcemia, that is spasm and hyperactivity, deep tendon reflexes, muscle cramps, abdominal cramps. Excess leads to hypercalcemia that results in constipation, muscle weakness. Also, it affects conduction of electrical impulses in the heart, calcium stones in the urinary tract, impaired kidney function, and impaired absorption of iron leading to iron deficiency. What about phosphorus? It is one of the components of the bone and also play important role in energy processing. Deficiency of phosphorus leads to hypophosphatemia. An example of phosphatemia is rickets. Excess of phosphorus leads to hyperphosphatemia, which results in kidney failure. Magnesium helps in processing of ATP and is required for healthy bones. Deficiency of magnesium level leads to hypomagnesia, which results in irritability of nervous system with spasm of hands and feet, muscular twitching and larynx spasm. Excess of magnesium leads to the hypermagnesemia, which results in vomiting, nausea, impaired breathing and low blood pressure. Zinc is necessary for several enzymes. Deficiency of zinc leads to the short stature, anemia, increased pigmentation of the skin, impaired gonadal function, enlarged liver and spleen, impaired wound healing and immune deficiency. Excess of zinc leads to suppression of copper and iron absorption. Iron is required for protein and several enzymes. Deficiency of iron leads to anemia and excess leads to iron load disorder. Iron deposits can occur in organs, particularly in heart. Manganese is a cofactor in enzymatic functions. Deficiency of manganese leads to the fainting, hearing loss, weak tendons and ligaments. Excess of manganese interferes with the absorption of dietary iron. Copper is crucial component of many redox enzymes. Deficiency of copper leads to anemia or pancytopenia, which is a reduction in the number of red and white blood cells as well as platelets that may also lead to neurodegeneration. Excess of copper interfere with the formation of blood cellular components in the body. Iodine is essential for the biosynthesis of thyroxine, a form of thyroid hormone. Deficiency of iodine leads to the developmental delays problems. Excess of iodine leads to malfunctioning of thyroid gland. Selenium is essential cofactor to the activity of antioxidant enzymes. Deficiency of it leads to Cation disease and Cushing-Beck disease. Excess of selenium leads to the garlic smelling breath, gastrointestinal disorder, sloughing of nails, hair loss, fatigue, irritability, and neurological damage. Molybdenum is important part of three enzyme system: xanthine oxidase, aldehyde oxidase, and sulfite oxidase. It is an important role in iron utilization, in carbohydrate metabolism, and in uric acid formation. Also, it has important role in sulfite deoxyfication. Deficiency of molybdenum may affect metabolism and blood cell counts, but as this deficiency is often alongside other mineral deficiencies such as copper, there is a little data on toxicity caused by excess of molybdenum. What are vitamins? These are organic compounds that we require in small amounts. Vitamins classified into two: water-soluble vitamin and fat-soluble vitamin. A total of 13 vitamins essential for the human body. For human, there are 4 fat-soluble, which are A, D, E, and K, and 9 water-soluble, 8 type of vitamin B, and then vitamin C. Water-soluble vitamins required to be consumed more regularly because they are easily eliminated, are not readily stored in body. Urinary output is a very good predictor of water-soluble vitamin constipation. Several water-soluble vitamins are synthesized by bacteria. Fat-soluble vitamins are absorbed through the intestines with the help of fats or lipids. They are easily accumulated in the body because they are harder to eliminate quickly. Excess levels of fat-soluble vitamins are more common than with water-soluble vitamins. This condition is called hypervitaminosis. Patients with cystic fibrosis require to have their levels of fat-soluble vitamins carefully monitored. Now, vitamin A, chemical name of vitamin A is retinol and retinoids and carotenoids. It is fat-soluble vitamin. Deficiency of vitamin A leads to night blindness. Overdose of vitamin A leads to ketomalacia, which is the degeneration of cornea. Vitamin B, its chemical name is thiamine. It is water-soluble vitamin. Deficiency of this can cause diseases like beriberi, Wernicke-Korsakoff syndrome. Overdose of vitamin B are rare hypersensitive reactions resembling anaphylactic shock when overdose is due to injection. Vitamin B2 chemically is riboflavin. It is water-soluble vitamin. Deficiency of vitamin B2 can cause disease, arbuopleniosis, which means mouth lesions, seborrhea, and vascularization of cornea. Vitamin B3 is chemically niacin. It is water-soluble vitamin. Deficiency of it can cause disease pellagra. Overdose of it leads to liver damage, skin problems, and gastrointestinal complication. Vitamin B5 is chemically pantothenic acid. It is water-soluble vitamin, and deficiency of it causes paresthesia, which is tingling, prickling, or numbness of the skin with no apparent long-term physical effect. Vitamin B6 is chemically pyridoxamine or pyridoxal. It is again water-soluble vitamin, and deficiency of it causes anemia. Overdose can cause nerve damage. Proprioception is impaired. Vitamin B7 is biotin. It is soluble in water, and deficiency can cause disease like dermatitis, enteritis. Vitamin B9 is folinic acid, again water soluble, and its deficiency can cause birth defects during pregnancy such as neural tube. Vitamin B12 is chemically cyanocobalamin, hydroxycobalamin, and methylcobalamin. It is soluble in water. Deficiency of it leads to disease called the megaloblastic anemia, which means the red blood cells are without the nucleus. Vitamin C is ascorbic acid, which is soluble in water, and deficiency can cause scurvy. Overdose of vitamin C results in diarrhea, nausea, skin irritation, burning upon urination, depletion of copper, and increase the risk of kidney stones. Vitamin D is chemically ergocalciferol, cholecalciferol. It is soluble in fat. Deficiency of this causes rickets, osteomalacia. Recent studies indicate higher risk of some cancers. Overdose of this can cause hypervitaminosis D, which is indicated by headache, disturbed digestion, weakness, and tissue calcification. Also may lead to increased blood pressure. Vitamin E is chemically tocotrienols. It is soluble in fat, and deficiency leads to include hemolytic anemia in newborn babies, while overdose of it causes higher risk for congestive heart failure. Vitamin K is chemically phylloquinone, menaquinone. It is soluble in fat, and deficiency may increase tendency to bleed. Overdose of it may include the effects of warfarin. Energy requirements of human. Basal or resting metabolism is used as fundamental assessment of human energy needs. This is measured while the individual is totally inactive and thermally neutral. It is considered an assessment of the energy conversion required for important functions. This includes the energy used by such continuous functions like the neural, cardiovascular, respiratory, and liver functions, and are also energy consumed for the survival of other body cells. The amount of energy extended in basal metabolism is higher during the growth and in women during pregnancy and lactation because of the high cell multiplication rates. Basal metabolism of an average size young adult male is 300 kilojoules per hour, but may be higher in pregnant and lactating women, maybe around 400 kilojoules per hour or as low as 150 kilojoules per hour in young children. This results in individual energy requirement variation from 3600 to 9600 kilojoules per day basal requirement. Living in hot or cold environment also affects the energetic requirements. Nutritional adaptation. It is observed that not All people can survive well at high altitude or under intense ultraviolet radiation. Similarly, there are major differences around the world in how effectively our bodies process particular type of food. In addition, some people live favorably on daily diets that would be at a starvation level for others. Different human populations not only eat different food, but their digestive system works in a different way. For instance, the Inuits of Alaska, northern Canada, and Greenland traditionally ate fat more than most other population, and their gastrointestinal systems apparently are more competent of breaking fats down for use by their bodies. This indicates that adapting to local nutritional fitness has led to the evolution of related genetic differences among the populations of the world. Many Indians in the southwestern United States have what has been described as thrifty gene. Their bodies are unusually efficient at utilizing the calories in their food. Thus, they need to consume less than other people at their size in order to maintain a stable weight. For example, Tohono of Odham Indians of southern Arizona, lactose intolerance. The best documented differences in nutritional adaptation relates to milk or lactose. In the period of the following World War II, many of the most prosperous countries of the North Temperate region, especially the United States, decided that the food shortages of many countries could be aided by food supplementation. Among the readily available food supplies in the temperate countries was milk, which was dehydrated and provided to many of the countries which are having food shortages. By the year 1960s, it was observed that in many of the populations, these food supplements often resulted in widespread diarrhea, and further research showed that many adults developed a diarrhea when they ingested significant quantities of milk. Later, research showed that a major population of world's population cannot digest the lactose contained in fresh milk products because of the lack of the enzyme called lactase. This gut enzyme converts lactose to sugar, which may be converted to energy in the normal biochemical chain. This figure shows you the lactose intolerance and the activity of the lactase enzyme, which I just mentioned, that lactose changes into sugar, which changes into the energy. Lack of this enzyme results in the loss of food energy and irritation of the intestine, causing diarrhea and other undesirable effects. Infants and young children in all population have this enzyme, but in many groups this enzyme disappears in older children, producing lactose intolerant adults. The process, like fermentation, involved in the production of yogurt and cheese break down lactose into digestible forms. Therefore, the problem arises only when the population use milk or its products in fresh forms, such as milk, cream, or very fresh cheese. The ability to produce lactase is genetically controlled. The gene that codes for this enzyme is present on chromosome 2. The studies of lactose intolerance show that a population is best adapted to its traditional nutrient environment, and therefore any change in the environment are likely to be stressful. Comparative dietary and nutritional adequacy. According to Harrison, the diet of early precursors cannot be directly determined, but we can assume on its composition based on the diet of our nearest relatives, the apes, and the preserved evidence of the early hominoid forms. The teeth and jaw structures of the earlier hominids indicates the best clues for their diet. In general, teeth become smaller in the size in more recent forms, but it did not show high degree of specialization. Some of the earlier hominoid forms developed teeth which are presumed to indicate a more vegetarian diet. Hunters and gatherers. It was commonly thought until quite recently that during the evolutionary process, hunting became an increasingly important food source. The reasons for this belief were multiple. Firstly, most of the artifacts found utilized for hunting, animal slaughtering. Secondly, early cave arts, and there is evidence for religion focused on hunting. Even the contemporary world, most populations prefer a high meat diet. While hunting and meat eating were important in the early human diet, recent research indicates that meat was never the major energy source at any stage of human evolution. In addition, such groups quickly substitute food items to their diet when the regular trade was established. For these reasons, it makes doubtful that quantitative nutritional information on the diet of hunter and gatherers before the development of agriculture. Throughout the 1960s, the diet some Sam in South Africa remained relatively unaffected by the external factors. The diet of Kung San has been incompletely analyzed for nutrients. For this group, meat contributed less than one third of the daily energy intake, and their food were diversified during the seasons of the dietary survey. According to Lee, in their food, over 20 species of roots, melons, bulbs, and dried fruits were included. A similar diversity of food has been reported for most of the hunters and gatherers. It appears that the diets of hunters and gatherers must have been nutritionally balanced, and also the common deficiency found in more recent populations were absent or quite rare in the hunter and gatherers. Now let's see in agriculturists and pastoralists. Early agricultural societies with limited domesticated plants also continued to rely on animals for certain important nutrients. Only these populations developed large enough to support the large villages, craft specialization, and the beginning of urbanization and civilization. The nutritional sufficiency of the plant and animal complexes are not similar, and the kinds of the nutritional deficiency varied according to the basic crops. The highly populated area of Eurasia has a diversity of domestic animals and the crops. The wheat and the millets contains carbohydrates and protein. Various fruits and vegetables provided sufficient minerals and vitamins. The rice-based food complex extending from Japan and Korea south to Indonesia and east to parts of India supported a population but had deficiency of vitamin B1. This deficiency occurred because polished rice is quite deficient in vitamin B1. In America, the potato-based diet of highland South America and maize-based diet of Mesoamerica supported almost 90% of hemisphere population. Out of the two, the South America complex was nutritionally more secure for various reasons. Firstly, the potato is high in carbohydrate but low in proteins. Potato diet was supplemented by seed-producing Chenopodium that contain more protein than wheat. Secondly, in highland areas had the reasonable supplies of meat. Clear evidence show in this area undernutrition is very common as a consequence of its currently poor economic status. Maize crops contain a better amount of protein than root crops such as potatoes, but it is lesser compared to the Chenopodium or wheat. Domestic varieties of beans were major crop and an important protein supplement, but the main problem was the lack of appropriate domesticated animals. In central Mexico, dogs and turkeys were raised as food. In fact, special hairless breeds of dogs were developed for cooking. Maya was another maize-sized population which may have been affected by nutritional problem. The most concrete evidence of the maize-based diet can lead to niacin deficiency. The basic foodstuffs are very low in niacin, and in the times of economic distribution, the symptoms of pellagra become common. In early 1900, the lower classes of the southern United States who had a maize-based diet had high incidence of serious nutritional deficiency disorder. Protein and population density association. By the year 1500, most of the population centers had developed to various degrees. The vast majority of agriculture population continued to depend on the foraging to provide a significant part of their diet. That is why the density of the population supported by the particular system is closely linked with the availability of fishes, edible mammals, and milk and its products. Many have assumed that protein, with the required complement of amino acids, was the key element. The diets based on only a few plant sources may result in a number of serious deficiency syndromes. The early explorers found among the maize-growing population, American Indians of the eastern United States, the largest densities are around fish-rich waters such as Narangas Bay in Rhode Island and the brackish Chesapeake Bay. Populations in sub-Saharan Africa provide equally interesting examples of protein population density association. It might be argued that people simplify the taste of the meat is desirable. On the other hand, some societies rate the value of the fish in relation to its relative fatness. So it can be concluded that in the evolutionary process, the genetic development of taste for fat has been genetically selected and the humans seem to capture food which provide nutrients crucial for their survival and well-being. Nutritional adaptation in extreme environment. An extreme environment can be defined as an environment where basic needs of human beings like collection of food, shelter, and protection require intense efforts. One important feature of these environments is that an error in judgment can cause serious consequences. When faced with hot, cold, high altitude, and human beings either try to modify their environment accordingly or adapt their physiology to fit the environment or may use combination of these two strategies. The diet of human varies in quantity and composition in different climatic regions. Although much of this variation may be due to availability of food in that area, selection of certain types of food or adaptation to some of the dietary habits which can help acclimatization process in that particular environment. Most of the studies on relationship of extreme environment and diet are the outcome of military research or expeditions to mountain and polar regions. Under these types of conditions, high energy expenditure not always compensated by adequate energy intake. Nutritional adaptation in high altitude. There are 140 million permanent inhabitants of high altitude in Himalayas, Central Asian, Eastern African, Andean, and Rocky Mountain region. Permanent residency is restricted to about 4,300 meters, although some ethnic groups, for example miners in Peruvian Andes, are reported to live at heights of 5,500 meters for a short period of time. High altitude presents in extreme conditions like hypoxia, high solar radiation, cold. Also, there is a psychological stress. The high altitude areas are also arid in nature with sparse vegetation and shortages of drinking water. These factors can vary in magnitude depending upon the location of the area and the season of that area. Food intake and energy requirements in high altitude. Many studies have shown that individuals lose significant amount of body mass during a climb or a stay at high altitudes. Weight loss in high altitude is mainly caused by malnutrition, probably due to hypoxia. Calories consumption can be reduced by 40% at high altitudes, resulting in negative nitrogen balance. High altitude exposure leads to the reduction in calories consumption and it is coupled with increased metabolic rate. This is considered as a major cause of weight loss. The taste thresholds for sweet and salt modalities have been found to be elevated, whereas for bitter and sour modalities are reduced. The leptin levels also decreases at high altitude and it is considered Major cause of anoxia. Nutrients requirement at high altitude. Let's take each of them one by one. Carbohydrates. High carbohydrate diets are beneficial at high altitude. Carbohydrates provide higher energy per mole of oxygen. Diets high in carbohydrates are shown to enhance the glucose metabolism at high altitude. Studies on Indian residents at high altitude show that up to 60% energy is derived from carbohydrates. Proteins. Negative nitrogen balance is reported at high altitude. In a well-controlled study with 12 grams per day dietary nitrogen intake, it has shown a positive balance. After acclimatization, there is no alteration in protein metabolism at high altitude when food intake was adequate with protein at sufficient level was ensured. Fats. After acclimatization at high altitude, it has been studied that the utilization of fat by feeding up to 325 grams per day, and it was found 95.5% fat digestibly with almost constant levels of fecal fat. In a controlled study, which was conducted by Sridharan, no adverse effect on digestion under high altitude was observed. Iron, the requirement of increased hemoglobin synthesis during initial phase of stay at high altitude are fulfilled by redistributing body stores and from dietary iron. Urinary excretion of zinc is more during physical exertion as observed during an expedition to Mount Everest. Zinc. Reduced zinc levels can lead to anoxia. Zinc supplementation has been found to be beneficial in women mountaineers in controlling weight loss, and their leptin levels also remain unchanged. Nutritional adaptation to cold environment. For providing nutritional support in a cold environment, energy requirements are main considerations. Exposure to cold increases energy requirements. Energy requirement in cold environment are influenced by various factors like intensity of cold, speed of wind, physical factors like the melting of the snow, etc. Johnson and Karg, they reported that individuals in cold climate normally eat more than those in the warm climate, whereas Gray et al. Suggested that increased energy requirements are caused due to the hobbling effect of the weight clothing and associated with efforts of locomotion. As technology has improved, the weight of cold weather clothing has decreased. However, clothing is still a considerable burden. It appears that heat loss in cold environment can be reduced through clothing and behavior. Also, skeletal muscle contraction either during voluntary exercise or involuntary shivering are the major source of metabolic heat produced to protect against cold stress. Severe losses of blood weight in cold environment complicate the normal physiology of the body. Thus, it is important during physically active conditions to maintain the adequate intake. There is a common belief that cold climate conditions lead to increased appetite. However, reported increase in appetite is also associated with changes in other aspects of individual's environment, such as increased activity levels, energy expenditure due to thermogenesis, social isolation, and modification in the diet. In animals, increased energy expenditure caused by increased thermogenesis due to cold environment is compensated by increased intake. Fat metabolism in cold environment. Human can adapt in cold environment over a period of time to a high fat diet. Whereas Indian Antarctic expeditions have common observation of increase in body weight that is mainly due to increased intake. Several factors are responsible for an enhanced appetite in cold region that includes cold temperature, palatability of food, changes in physical activity habits, and emotional factors, for example, loneliness. The low leptin levels may be responsible for increased food intake. The dietary pattern of natives of Arctic and subarctic regions and their obvious success in coping with harsh environment have influenced Arctic explorers to choose diets high in fat in general, believe that this may be helpful for their adaptation. Such information is largely anecdotal and probably relates more to the availability of the local food, that is the seal, fish and whale, and familiarity of Eskimos with these food. However, such diets are rich in fatty acids which play important role in the prevention of cardiovascular diseases. There is evidence to suggest that stimulation of carbohydrate oxidation by ingestion of ephedrine caffeine mixture, and it can help to improve cold tolerance in human. Nutrition adaptation in hot environment. In hot environment, adequate fluid replacement overshadows all other consideration of nutrient requirements. Drinking adequate water in heat prevents dehydration, heat illness, and reduced performance. Hypohydration depends in large part upon sweat rate, which in turn is determined by workload and duration. Other environment factors are solar load, wind speed, relative humidity, and clothing. In hot environment, energy expenditure is increased by small but significant amount because of the additional work of increased sweat glands activities and ventilation. Consortio estimated that there is a rise of approximately 10% in energy requirement at the temperature of 38 degrees Celsius. Excessive nitrogen losses are reported in perspiration of unacclimatized people but not in acclimatized people. Micronutrient requirements in hot climate. There is no extra need of iron and vitamin in hot environment. Although loss of water soluble B vitamins is minimal, a deficiency could occur over time from profuse sweating coupled with an insufficient dietary intake. Thiamine, riboflavin, niacin, and vitamin B6 are important to energy metabolism. Thus, it is important the level of these vitamin intakes should be adequate to amount for food consumed. It was found that sodium chloride requirement increases due to loss in sweat. 15 to 16 grams of salt normally taken in diet is quite adequate for acclimatized people. Supplementation of potassium in drinking water may enhance the process of acclimatization. Detailed studies on effect of consumption of brackish water of Rajasthan containing high levels of fluoride and nitrate have also been carried out. No adverse effect and symptoms of fluorosis up to 2 years of intake were noted in adequately nourished people, although the excretion of fluoride was found high. To sum up this module, let's see. The nutrition is the process of taking food and using it for growth, metabolism, and repair. Good nutrition is an adequate, well-balanced diet combined with regular physical activity. It is very essential for good health. Poor nutrition can lead to reduced immunity, increased susceptibility to diseases, impaired physical and mental development, and reduced productivity. Human body requires 7 major types of nutrition. They are protein, carbohydrate, fat, vitamin, mineral, fiber, and water. Fundamental to the assessment of human energy need is basal or resting metabolism. This measure of energy used is determined while the individual is totally inactive and thermally neutral. Individual energy requirement, which vary from 3600 to 9600 kilojoules per day, is basal requirement. When faced with hot, cold, high altitude terrestrial height which is above say 2700 meters, and human beings either try to modify the environment accordingly or adapt their physiology to fit the environment, or it may use a combination of these two strategies. The diet of human varies in quantity and composition in different climate regions. Many studies have shown that if individuals lose significant amount of body mass during a climb to or a stay at high altitude. Weight loss in high altitude is mainly caused by malnutrition, probably due to hypoxia, the reduction in calorie consumption, and with increased metabolic rate. High carbohydrate diets are beneficial at high altitude. Diets high in carbohydrates are shown to enhance the glucose metabolism of high altitude. There is a common belief that cold climate conditions lead to increased appetite. Several factors are responsible for an enhanced appetite in cold region. Includes cold temperature, palatability of food, changes in physical activity habits, reduction in leptin level, and emotional factors.